let's turn to page 3. Unfortunately, this is not complete. I only did it like about half an hour ago. So I only managed to cover until about 2/3 of your syllabus. Yeah. I mean, half an hour before the maths lesson. Good afternoon. Okay, so this is what it's going to be like. Everything I'm going to show you, you either need to memorize or you need to practice. The green color ones are the ones you need to practice. Okay, everything else, memorize. So, page 3 on your textbook, base quantities, memorize. Come in, sit down quickly. Hurry up, hurry up, hurry up. Page 4, prefixes, memorize. Okay, what is your 10 to the power of 9, what is it, so on and so forth. 10 to the power of -9, what is it? Page 5, precision of the meter ruler. Your meter ruler has the same precision as your ruler in your pencil case. You read up to 1 mm only. Okay, so that is just 1 mm. For your vernier calipers, it's even better. It is 0.1 mm. Micrometer screw gauge, 0.01 mm. Even more precise. Okay, the precision depends on the number of decimal places that you have. The more decimal places your instrument gives you, the more precise it is. Sometimes they write this precision of the meter ruler as 0.1 cm. Isn't that the same as 1 mm? Same thing, don't be confused. Sometimes they tell you vernier calipers, okay, precision is 0.01 cm. Same thing as 0.1 mm. They're all the same. So for me, I chose to memorize it this way. All of it just divide by 10, divide by 10. Very easy. And then I know how to convert from millimeter to centimeter anyway. Okay? Now, how do we avoid errors? There are a few types of errors. First, parallax error. How do we prevent that? You must read perpendicularly. Your line of sight must be perpendicular to the ruler. If you're reading from the side, that means at an angle it is no longer perpendicular, and that is when parallax errors occur. Other types of errors are random errors. Maybe one side thicker than the other side. Maybe you never put properly, so on and so forth. These are called random errors. So, human error, I'll talk about it later on. So random errors, we reduce them. I cannot eliminate them. I only can reduce them by taking average. So I do it many times, I take the average. So I reduce the errors. Human error, I'll talk about it later. So, page 9, reading of vernier calipers. Go and practice how to read. Confirm, something will come out. You also need to identify which one has positive error, which one has negative 0 error. Okay, so on page 9 you have a table over there. Whether it is positive error or negative error, you always subtract it from the observed reading. Okay, if it is a positive 0 error, then you'll be subtracting a positive number. If it is a negative 0 error, you'll be subtracting a negative number. But subtracting a negative number is the same as adding the number, right? That's where some students are confused. So the way to remember it is always subtract the error. If the error is positive, good. If it is negative, just change the sign. Just like in mathematics, minus negative number is positive. Same thing for your micrometer screw gauge on page 10. More of you all have trouble reading the screw gauge as compared to the vernier calipers, so just go and practice. Okay, this is something that if you practice, you will be able to get it right. Next, you need to know the definition of period. So it's the time taken for one complete oscillation. You need to know for a pendulum, a longer length of the string means that there is a longer period. Shorter strings, shorter period. The mass does not affect the period of pendulum. Does not affect. And the reading of a stopwatch, although stopwatch we always have 2 decimal places, 1 out of 100 of 1 second, we always just write it down as 1 dp. Why? Because there is human error. Your human reaction time. You take time to react. It's not like I tell you to stand up, you immediately stand up. Your brain needs to process. That takes about 0.2, 0.3 seconds. So even though your stopwatch can tell you up to 0.01 seconds, there's no point because we confirm have reaction time. So we always read up to 0.1 second only for the stopwatch. Page 20. You must memorize the definition of scalar and vectors. You must be able to give examples of these two. You must know the difference between distance and displacement. One is a scalar, one is a vector. One has no direction, the other has direction. Both of them have magnitude. Similarly, for speed, then you must know what is the formula and how you apply average speed formula. Total distance divided by total time. Not add up all the speed, divide all the speed. Total distance divided by total time. Compare that with the instantaneous speed. Instantaneous speed means the speed at that instant. If you go and run a 100 meter sprint, I can calculate your average speed. That is 100 meters divided by the time taken. But if I want the instantaneous speed, I'm referring to the speed at every single instant that you're running. Initially, what is your speed? 0. Initially, when you just started, you run. What is your initial speed? You start from rest, right? So it must be 0 lah. Then as you run, your speed increase, right? Otherwise, you'll be stationary there. Of course, your speed must increase. So you see your speed is changing. At every point in time, your speed is different. Probably you'll reach your maximum speed at around the 30 meter mark. Then you sprint all the way already, maximum speed. And page 23, know the definition and the formula of velocity. And of course, the application of average velocity. Same concept for average speed. Just take the displacement divided by time. Then definition of acceleration, know the units. Next, deceleration is retardation, which is also known as negative acceleration. Know the definition for uniform acceleration, that's on page 24. And the formula that we are all familiar with, v minus u over t. This is for uniform acceleration only. If your acceleration is changing, then I cannot find the acceleration. Only for constant acceleration that I can use it. So green color means you must practice. Then go and practice page 27 to 28. How do you describe a distance time graph? How do you describe an object? It can either be at rest, moving at constant speed, either increasing speed, known as accelerating, or decreasing speed, known as decelerating. Accelerating got two types. Either it is constant acceleration or non-uniform acceleration. Likewise for deceleration. Page 28 to 30. The gradient of a distance time graph gives you your speed. Gradient of a displacement time graph gives you your velocity. This is why you need to practice, you need to memorize. Then, how do we describe a speed time graph? Same thing, the object will either be at rest or constant speed, uniform acceleration, non-uniform acceleration, uniform deceleration, or non-uniform deceleration. You must be able to identify all these things from the graph. So, this is very important. Very likely to come out gradient of the speed time graph. What is that? Acceleration, yes. Area under the speed time graph. Also very important, distance traveled. Then, next we have free fall. Understand what free fall is. When I drop this, is it undergoing free fall? Yes? Is that air resistance? So it's not free fall. Free fall is when it is falling down due to its weight only. Okay? So that means it must be a vacuum. Or unless we tell you, assume air resistance is negligible. Assume it is free falling. That means I'm telling you, no air resistance, nothing else. And acceleration due to gravity on Earth is 10 meters per square second. Every second, the speed will increase by 10 meters per second. And all objects, regardless of the weight, regardless of the mass, regardless of the area, whatever it is, they all fall with the same acceleration of 10 meters per square second on Earth's surface if there is no air resistance. Because if there is air resistance, I'm sure the paper will take a longer time to drop down as compared to the book. Okay? So if it is free fall, they all fall at the same time. Know the examples of contact and non-contact forces. know how to draw scale diagrams for vector addition. Practice adding parallel vectors. So parallel vectors means that either they are in the same direction, or to the right, or to the left, or up, or down, or directly opposite. So the opposite of right will be left. Opposite of up will be down. So these are parallel. Left, right, they are parallel. Up, down, they are parallel. So how do we do that? We draw a free body diagram. So you add all in the same direction, you add them up. Different directions, subtract them. Then you can find the resultant force. If the vectors are not parallel, meaning maybe like that, one over here and one over here, obviously they are not parallel, right? So we need to draw a scale diagram. Over here, this one, move over here, and this is my resultant force. Okay, go and revise on how to draw your scale diagrams for vector addition. Memorize the different effects of a force. It can stop a moving object, it can start a moving object, it can change direction, it can speed up, blah 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 blah. Know all of them. Page 52. Go and memorize Newton's first law of motion. What does Newton's first law of motion state? It states that, I didn't memorize that. It states that every object will continue in a state of rest or uniform motion in a straight line unless a resultant force acts on it. Yeah, that's Newton's first law. So I said compare with inertia. Do you remember the formula, the definition of inertia? Reluctance of a body to change its state of motion or rest due to its mass. Reluctance to change its state of motion or rest. Let me see if it is stationary, it doesn't want to move. If it is already moving, it doesn't want to stop. Compare that to your Newton's first law. Every object will continue in its state of rest, meaning if it's at rest, it will stay at rest. Or in a state of motion in a straight line. If it is moving, it wants to continue moving unless a resultant force acts on it. So it will happen unless I start to exert a resultant force. Okay? Then what is an unbalanced force? Unbalanced force is when you add everything up, all the forces up, you get something other than zero. If all of the forces add up to be zero, then it is balanced. If it is not zero, then it's unbalanced. Okay, so Newton's second law, memorize it, but I prefer the formula. Not that I have a choice, but isn't the formula much simpler than the definition? It's just 3 letters, F equals to ma. But to understand this, you need to memorize the definition. So go and do that. F over here is the resultant force, not any other force. Not any force that you like. It must be the resultant force. A will be the resultant acceleration. Common questions that will come out testing on this is, an object is moving at a constant velocity. State the resultant force. Why? Because constant velocity, that's why zero acceleration, that's why no resultant force. Okay? This is something we like to do. Newton's third law, also go and read the page 56, go and memorize the key ideas. Page 56, the key ideas are referring to what we just talked about. When forces are balanced, resultant force is zero, acceleration is zero. If it is at rest, it will remain at rest. If it is moving, it will continue moving. If it is unbalanced, then there will be an acceleration. And then you can start calculating based on either F equals to ma, or you can use v minus u over t to get the acceleration. Next, 57, know the definition of friction. Know the positive and negative effects of friction. How to reduce or increase friction. Know how to draw free body diagram. Free body diagram, use your pencil. Don't go and use pen. You draw wrongly, you want to use correction tape, but correction tape is banned. Not supposed to use it. Not supposed to use liquid paper. So use pencil, draw with the ruler. Label all your forces. No point having all the arrows correct, very nicely drawn, you don't label. You don't label means I don't know. I cannot guess for you. So you get 0. Note where you start the forces. If it is weight, it must start from the center of the box, because that's where the CG is. If it is air resistance, then you must see where the surface is in contact with the air. Note the magnitude of the force, meaning the length that you draw. You cannot draw 1 cm for 1 Newton and then you draw another 1 cm for 3 newtons. Cannot be. Longer length must correspond to a greater vector in magnitude. So next one is pressure. P equals to F over A. You must know how to use this formula. So practice. What is the relationship between F, A, and P? When force increase and the area is constant, pressure increase. Logical, right? Mathematics. When the force drops but the area is constant, the pressure also drops. When the force is constant, area decrease, pressure must increase. When the force is constant but the area increase, the pressure must decrease. You can look at this in terms of mathematics, or you can use your common sense. Take this pen, this stylus over here, big surface area. I poke myself, not very pain. But if I use the same force with a mechanical pencil, I poke my hand, it will be painful. Why? Small area. So it's got to do with pressure. Page 70, definition of mass and weight. Know the difference between them. Weight can change depending on the gravitational field strength. Mass is the amount of matter in a body. That means the number of molecules in you, number of atoms, all these don't change. So your mass is constant. Again, know the definition of gravitational field and the gravitational field strength. On page 72, we have a simple equation, formula, W equals to mg. This is weight equals to mass times g. We said that mass is constant for our body, so why does the weight change? It is due to the value of g, gravitational field strength. This one changes whether it is on Earth, if it is on Moon, another planet, it will change. That's why we have a different weight. In page 73, we have a table talking about the differences between mass and weight, what they are, what is the unit, how are they affected by different things, and very importantly, what you use to measure mass, what you use to measure weight. Must know. Okay, definition of inertia. So we said that already, it is dependent on mass only. Doesn't depend on anything else. So if there's a rest, it doesn't want to move. If it's moving already, it doesn't want to stop. It doesn't want to change direction. It stays in one straight line. Next, definition of and formula for density. Rho density equals to mass over volume. Same mathematical arguments can be used for this one. You have density equals to mass over volume. So as the mass changes, as the volume changes, you can also know how does the density change. Next, average density. Practice. Total mass over total volume. Common question. Alloy, made out of two metals, maybe gold and silver. Gold itself has a density of so and so. Silver has a density of so and so. I take maybe 1 cubic centimeter of gold, 1 and 2 cubic centimeters of silver, mix it up into an alloy. What is the average density? You need to find the total mass first. You need to find the total volume. It is not as straightforward as take one density plus the other density divided by 2. Not as straightforward as that. Similarly, okay, can you tell me what is this formula very similar to? We talked about it just now. Average speed, yes. Same concept. We cannot just add the 2 speed and divide. Just like this. I cannot just add the 2 density and divide. I need to find the total distance or the total mass divided by total time or the total volume. Okay, and over here I highlighted this. It is not average of 2 densities. Now page 84, moments. You must know the definition of moment of a force. Page 85, we have the formula, which is force times D. What is D? It is not any distance. It is the perpendicular distance from the line of action of force to the pivot. You must also know the units, which is Newton meter. There are other variations which are not SI unit, which will be Newton centimeters or kilonewton meters, so on and so forth. They are just variations. So, for example, what is this? How to calculate the moment? If I have this diagram over here, I have a pivot and I have a force. You are always given one force. You need to draw your line of action of force yourself. This blue color one, just extend it in both directions. So this is the line of action of force. Then the perpendicular distance from the pivot, the point that doesn't move over here, to this line, in this case, will be this distance, okay, in green. That is my distance that I'm interested in. But sometimes we have the force acting at an angle. It is not always the case where they act downwards, upwards, upwards, downwards. Because if that's the case, it's very easy to find out the perpendicular distance. Sometimes they give it to you at a slant. So if it is slanted, I need to draw the line of action of force myself. Just extend it both directions. Then, to find the perpendicular distance, I need to find a pivot, draw a perpendicular line to this line of action of force, perpendicular, then this is my perpendicular distance. Okay? The perpendicular distance is not this. Can? Page 87, definition for the principle, basically need to memorize principle of moments. It is only applicable for a system in equilibrium. How do we solve questions on principle of moments? Step 1, identify all the forces. Step 2, identify the pivot. This one is very easy. Next, determine the direction of moment. Does this force give you a clockwise moment or anti-clockwise? Does that force give you a clockwise or anti-clockwise? Identify all of them. Calculate all the moments, add them up for the clockwise ones. Calculate all the anti-clockwise moments. All the clockwise moment must be equal to all the anti-clockwise moment. Form an equation. Solve for the unknown. The unknown will either be a distance or a force. Regardless, you will have one equation with one unknown. Confirm. Then just solve for it. Page 92, know the definition for the CG, center of gravity. Know how to briefly describe an experiment to find the CG. Do you remember how? How to find the CG of an object? I thought I'd show you all. You take for example, an irregular shaped object, you punch a hole, then you suspend it, let it rotate freely. When it comes to a stop, drop the plumb line, draw a line down, the CG line somewhere there, choose another hole, let it rotate, draw another line. Where they intersect will be the CG. You must be able to describe that briefly. Then know the types of equilibrium. Before that, know the definition for stability. Know what does stability depend on, whether it's your base area or the location of your CG. Then on page 95, you need to know the different types of equilibrium. Types of equilibrium. There are 3 types. Your stable, unstable, and neutral. Okay, so that is all for chapter 5. And that was all that I was able to cover during my preparation. So, what free period? That was in my preparation. Anyway, this is only one period. You have 5 more minutes. Okay? Work, energy, power. So, on page 104, you must know the definition of energy plus unit. And we also need to know the different types of energy. You need to memorize the principle of conservation of energy. Very important, don't forget the last part. The total energy in an isolated system remains constant. Okay? And page 108, understand the conversion between GPE and KE for a pendulum. Okay, when it is at the highest point, that tells me that GPE is greatest and KE is 0. At the lowest point, KE is greatest and GPE is 0. The sum and the sum over here, they are equal because I cannot create, I cannot destroy energy. Only can keep converting. Page 110, work done. Sorry, this is page 111. Definition and formula. WD, okay, work done equals to force times the distance moved. And in your textbook, they use the letter S to refer to the distance moved in the direction of force. So you must know cases where, for example, you carry a book. Okay, so carrying the book, the force is upwards, but the direction of motion is to the right. So in this case, no work done because the direction of travel is perpendicular to the direction of force. You must know this. Okay? That's why there is no work done. Perpendicular. Then next on page 118, power definition and formula. P equals to work done over time taken, which is also the same as energy converted divided by time. Units, watts. We short form, the symbol will be just W. Okay, so next will be our state's kinetic model of matter.